So previously we looked at the desert and low dew point temperatures. Then we looked at July dew points for much of the country and moderate dew point temperatures between 60 degrees Fahrenheit and 70 degrees Fahrenheit. And the two jobs of dew point, and the first job is to give you a good read on actual vapor pressure in the environment. And when you have a moderate dew point between 60 and 70 degrees Fahrenheit, you have moderate vapor pressure at about 25%. Remember, the range is about 10% to 40%, so this is right in the middle. And you've got moderate water vapor content in the air. The second job of dew point is to give you a real feel of the air, and you do that by subtracting surface temperatures minus dew point temperatures. When you get something that's between about 15 to 20 degrees Fahrenheit or about 10 degrees Celsius, that's a moderate less difference of a drop there. That means there's less temperature needed for a drop to saturate air. That means there's more vapor in the air because you need less of a drop to get to that vapor and saturate the environment and lead to condensation. All of that vapor is coming right up from the Gulf of Mexico, especially in July, so that you can understand that this area is going to feel a little clammier. And that's the real feel that we were talking about. Let's look at another extreme situation of very high dew point temperatures. Dew point temperatures above 75 degrees, and those are rare. And let's look at what the actual vapor pressure would be in that case. So if we go out near 85 degrees on our Fahrenheit scale on the x-axis and go up to the saturation vapor pressure line, meet it, and then go over to the y-axis, we've got a y-axis at about 40 millibars of actual vapor pressure. That's why the 40 is there. That's about 4%, the upper limit of what the environment can handle before it all condenses out. These are situations that are particularly fraught with danger because the sweat from your body condenses right back onto your body and doesn't evaporate and cool you. So these are heat emergencies, and these heat emergencies you see on the map here in July tend to happen just inland from the Gulf of Mexico, in this area where the dew point is at around 70 or could go higher, and they don't have the ocean breezes to really try to aid in that evaporative feel. That can be right around here in Georgia, again, where you're inland a bit. This is a high dew point temperature. It indicates high actual vapor pressure and high water vapor content in the atmosphere. The second thing it indicates, by this very small difference between surface temperature and dew point temperature, it indicates a very small temperature drop needed to saturate the air. And of course that vapor is coming right up from the Gulf of Mexico, and it's a suffocating feeling when it actually impacts your breathing, that you can't exchange air as easily and you can't evaporate off that vapor as easily. So these tend to run into heat emergencies. Dew point, as we said, is a good measure of actual vapor pressure in the environment. It actually does a very good job of telling us how much water vapor is in the environment, so that we don't rely just on our real feel. We can get a measurement of it. Here's a case in point. You have two situations here, a very snowy environment and a desert environment. Which do you think has more moisture in the air? Well, you would observe a wet cold in this environment. So you can turn off the video here and you can just say, which of these pictures has more moisture in the air? And then when you come back to the video, let's do the science. So you observe here a wet, cold situation, and you observe a dew point that you measure at -2 degrees Celsius or 28 degrees Fahrenheit. So you take that over to 28 degrees Fahrenheit, right about there, and you go up to meet your saturation vapor pressure line, and then you go to your y-axis, and you're at about 5 millibars for your actual vapor pressure. Now, let's see what's going on in the desert. When we go to the desert, we observe a dry heat. A dry heat, it feels good, right? And look at this. The dew point is higher. A higher dew point tells us that there is more water vapor in the air. Let's look and see how much more. We've got 5 degrees Celsius, 41 degrees Fahrenheit. Let's go to our 41 degrees Fahrenheit here. Go up to the saturation vapor pressure line. Come to the y-axis. Oh, you're at 10 millibars for an actual vapor pressure. That's twice as much that's twice as much water vapor in the air as your snowy environment. And you know what? That makes sense, because snow is precipitation, yes, but it's not that much precipitation. In fact, 10 inches of snow equals 1 inch of rain. So this can be a very dry atmosphere. It has a very high relative humidity, but that's fooling you because there's not as much water vapor in this atmosphere, and there's more water vapor in that atmosphere. This is a good extreme situation of showing you that dew point is a better predictor of actual vapor pressure, certainly, than relative humidity. I will see you on the next video for what all this condensation leads to, and that is fog and clouds. See ya.